So we have discussed in the earlier classes regarding the silicate minerals. No? So as we know that silicates form the 90% of the crust, the rock composed of silicate minerals. They are mainly 90% of the earth crust, and there are certain non-silicate minerals. Okay, but the non-silicate minerals only some are very important, or some are important. Uh, few are either very common or they play a very important role in the art processes or having some economic value. Okay, so as we discussed, the non-silicates minerals are carbonate, sulfate, oxide, fluoride, sulfides, phosphate, and native mineral. So whatever the rocks we are having, they are mainly composed of silicate minerals, and silicate mineral form the 90% of the earth crust, and there are certain non-silicate minerals and they are very few. Okay, so one calcite, that is carbonate. Calcite is a non-silicate mineral which is composed of which consists the carbonate rocks. Okay, so and there's limestone. These are composed of calcite. Marble is composed of calcite. Okay, limestone is a sedimentary rock. Marble is a metamorphic rock. Okay, so both are from the calcite. So and some of the calcites from the cells of the organism, no? The bone, teeth, okay, they are composed of calcite. So it is mainly composed of calcium carbonate. Then related to this is one mineral, dolomite. Okay, it is composed of magnesium and calcium. Okay, so dolomite consists both magnesium and calcite consists the calcium carbonate. So it is the calcite is looking like that, and dolomite is more or less similar to calcite, but because of presence of some magnesium, they are a little bit dark in color. Okay, so calcite is important in the sense that the marble is composed of calcite and limestone is composed of calcite, and limestone is used in the cement production. Okay. Then magnetite, these are the oxide mineral, magnetite and hematite, important oxide mineral. They are iron oxide. Okay, so many of the rocks, igneous and sedimentary rocks. Okay, sandstone is a sedimentary rock. Okay, and we have igneous rock, plutonic rock. They consist of metal oxide. Okay, so they are maybe magnetite or maybe hematite. Okay, and hematite, they put the reddish, this is hematite. Okay, they put the red color. Okay, they put the red color in the sandstone. Some of the sandstone you will see they are reddish in color. These are reddish in color sedimentary rocks are because of the presence of some more amount of hematite. Okay, so these are two magnetite and hematite important oxide mineral. Okay, all these minerals are in our lab. Okay. Then sulfite, you know, galena, these are the galena. Okay, and pyrite, iron sulfide. Okay, sometimes pyrites are called fool's gold because it is more or less similar to gold. Shining is like a gold. Okay, but they are the iron. Sorry, iron sulfide. Okay, pyrites are the ore mineral for iron. Okay, so this is the pyrite and this are the galena. Now, after studying this, so there are certain criteria to identify the mineral in the hand specimen in the laboratory or in the field. So we can study the hardness, whether the mineral is how much harder it. We can use the Mohs hardness scale. No, then you can check the density from the specific gravity. Then form, whether the cleavage, plane of weakness are present or not. What is the color? What is the streak? What is the association is sometimes important, in which we know the if we have a granite rock, there must be some quartz and feldspar. Okay, but if you have a dark color rocks, then it will be associated with some pyroxene mineral. So the association is important, where it is from, whether it is from the lava or from the magma. Then there are certain mineral having certain taste, and certain order. So these are some of the criteria which help us to identify the mineral. Now, we discussed the earlier in the last class we discussed about the clay mineral. Na? The clay mineral, we have different varieties of clay mineral, and they are formed from mainly from the weather product of the potash feldspar. Okay, potash feldspar autoclase is one of these. Okay, so this alkali feldspar, when it weathered, they form certain mineral, we call them clay mineral. Okay, some of the clay. That what is the engineering consideration of the clay mineral? So we have a few varieties of clay minerals. Out of these, some are important. Kaolinite is one of the common clay mineral. Montmorillonite is common clay mineral. Then we have illite and chlorite. Mainly these four are most of the common mineral. There are other clay minerals also. Now, if you see, montmorillonite is a dangerous type of clay. Okay, in the cut when you found in road or tunnel, because it is expandable in nature, which causes slope or wall failure. So what is this? Montmorillonite is a kind of clay. When it is wet, it swell because it retain the water and it swell. And what happens if you have in a road cut or a tunnel cut? Okay, you are cutting the road or digging a tunnel. You are going through the clay, which is mainly composed of montmorillonite. What happens in the road slope? If it is composed of clay during the rainy season, what will happen? It will retain the water and it will swell and it will fail. Okay, so clay are very fine grains. You know, they have pores. They have pores. If you see, there is a clay, very fine grains. Okay, these are sand. These are a little bit bigger, and these are gravel. Now, there is one term you may be knowing, the void space or pore space. Pore space is the intergranular space between the grains, and porosity of soil or porosity of a rock is the ratio of the voids to the total volume of the solid. Suppose you are having a certain amount of clay and you measure the total volume, then you measure the volume of the voids, intergranular space. That ratio is called pore space, porosity. Okay, so here you see these are very fine grain. They are very fine grain, and clay, they are highly porous. There are two terms, porosity and permeability. Okay, porosity, as we discussed, they are the ratio between the void intergranular space to the total volume of the solid. Now, in case of clay, their porosity is high, but they are impermeable in nature. They retain water, but not allow the water to pass through it. Because why? There are intergranular space, but this space, the interconnections between the pores are not there, because as they are very fine grains, they block the space, block the interconnection. Okay, because of the minute grains. But in case of sand, they are bigger in grain, they have pores, and these pores are interconnected. So they porous as well as permeable. That means they yield the water and they allow to pass the water through the grains. In case of gravel also, you have bigger grains. Okay, so they can retain the water and as well as they allow the water to pass between the interconnecting pores. Okay, so that is why in gravel bed they are good for as aquifer, that means for groundwater prospective zone. Okay, so because of this nature, because of this nature, uh, the montmorillonite, this is a clay, they are very fine grains and their porosity is more, they can retain the water, and as there is no interconnecting pore space, their pores are not interconnected because minute grains block the pores, okay, connection. So they can retain the water but don't allow to pass the water. So as a result, during the rainy season, they will swell and it will cause the failure of the slope. বুঝে পয়সা?
Yes, sir.
Okay, good. Then kaolinite. Okay, it is another kind of clay mineral. It is used in the ceramic industry. It is not expandable and would not absorb the water. Okay, it is used in now in case of clay, you are working with the clay. Now you have to understand which clay you are working. If it is in a road cut, if it is kaolinite, it's okay, it is somehow stable, but it is montmorillonite, it is totally unstable. So clay is used as an important material in the construction industry, both as a building material as well as a foundation of the structure. So it is very important for you people also. Clay can be used in the materials in the construction, and you can put the foundation of structure sometimes on the clay. So it has pore drainage. As I discussed, it has pore drainage because the soil tends to stay wet and soggy when it is affected by water. While it is wet, it can be easily compacted. Okay, so when you want to compact the clay, you have to wet it. So if you compact it, then water will be removed from the clay. Okay, so and that is why in an area, this is one of the problem. So suppose in a town area, if your surface or say subsurface below certain depth from the surface, if you have a clay layer, it will not allow the rainwater to percolate. So surface runoff will be more. Okay, when the surface runoff will be more, there will be a problem of waterlogging. But if you have a coarse seam in the surface, below the surface, okay, so the rainwater can easily percolate downward. Okay, surface runoff will be less, and then waterlogging problem will be less. This is one important point. So when there will be in the town area waterlogging will be there, you have to check what the kind of materials are there. Okay, this one. So it has pore aeration because the soil particles are small and closely spaced. It is very difficult for air to enter or leave the soil. So same thing, the soil, this clay are the finest particle. Okay, so if you say gravel, pebble, okay, then sand, and then silt, then clay. Okay, clay is the smallest particle. Okay, and because of this, they block the interconnecting pore space will be not there. Pores are there, but no, there will be no interconnection because blocked by the minute grains. Okay. It is again, if you go to the agriculture purpose, it can as they are very minute grain, it can has very high nutrient reserve. Okay, reducing the need for fertilization. Okay, again it can retain the water, so it will be helpful for growing the plant. Okay, in a drought area. So clay is better for planting the any of the vegetation than the in case of sandy soil, because in the sandy soil, that is why sandy soil is not good for any kind of plantation, because they cannot retain the water, they cannot hold the nutrients. Okay, sandy are having porosity is there and permeability is there. Whenever the water fall, they cannot retain, all the water will going down, percolate through the soil. Okay. Now, after considering the engineering aspects of clay, because engineering clay, we are working many a time with the clay in the surface. We have the clay and sandy soil, alluvium. So we have to work with the clay. So you have to have a certain idea in the regarding the clay. Now, engineering classification of the mineral. So earlier we classified the mineral as silicate, oxide, sulfide, like this. No? So you can classify based on their engineering properties. Okay, based on their influence on the performance of the rock or soil. Okay, so a partial listing of the potential mineral we can the soluble. Some of the minerals are very soluble in water, say calcite, dolomite, gypsum, halite, zeolite. These are soluble minerals. So so limestone, it is composed of calcite. Marble, it is composed of calcite. Now you are constructing a dam in an area where you are putting your structure on a limestone bed or a marble rocks bed. Okay, what will happen? Why we are constructing a dam? To store the water. In the upstream side, we have a reservoir. Okay, now you are putting your structure on the limestone bed without considering these things. And limestone, you know, it is composed of calcite. What will happen? Later on, this calcite of the limestone will be dissolved in water and your structure will fail. Sorry. And there will be a percolation of the water below the dam. So your purpose for storing water will not be suitable for there. So this is one important. So you cannot put your structure of a dam in an area which are composed of, say, limestone, marble, or all this type of mineral. Again, if you putting your suppose you are going through a tunnel and your roof is composed of limestone. Again, if this limestone will be dissolved in water, again there will be problem for water leakage or failure of the roof. So these are the points. Then unstable mineral, marcasite and pyrrhotite. Pyrrhotite is again a iron ore. So these are very unstable. Why these are unstable? We discussed. Why they are some of the mineral unstable, stable, or more stable. Because these are all depends on the atomic bonding between the cations and anions. How the cations are placed or anions are placed within the cations. We discuss those things. So if there are atomic bonding and there is space between cation and anions, or anions are very small, then if it is not fit accordingly, then this mineral will be unstable. Okay, potentially unstable mineral. Okay, Notronite, iron rich montmorillonite. So you know iron montmorillonite. If it is potentially unstable because it can retain or hold the water and it will swell. So it become in the road cut or a tunnel cut, it cause the havoc. And these are some of the minerals. Mica is also a unstable mineral. Release H2SO4, okay, on weathering. So pyrite, because the FeS, pyrrhotite, again iron sulfide and others, lead sulfide, PBS. If these are the minerals during weathering, they will release the H2SO4 to the atmosphere. So you have to take care of these things. Okay. Clay mineral, okay, like some chloride, then this mica. Okay, these minerals having low coefficients of friction. Okay, this the swelling mineral, as we discussed, clay minerals are mainly swelling mineral. No? Elite, kaolinite, montmorillonite is more swelling because of the impermeable in nature. They are porous but impermeable, so they will show. So that is why if you have a sliding landslide or debris slide, okay, it is more during the rainy season. Okay, why you have more debris slide in Guwahati during rainy season? Because this material, they hold the water. Okay, so shearing strength will be reduced by the water, absorbed by the materials, and they will fail. Alkali reactive minerals, so which interfere with the cement. So these are mica, then quartz, gypsum, and they are react with the cement. This we discussed earlier, na? The iron oxide metallic minerals are having high density than the rock forming minerals. Okay, so mineral with contributing arsenic to the groundwater. So all of you have you know that the arsenic problem in Assam. No, why this arsenic problem in groundwater is that if you have rocks which are having arsenopyrite or arsenolite or prostite, okay, this mineral, if these minerals are in the rock is composed of mainly say arsenopyrite is one mineral. What will happen? This mineral in the rock, they leach the arsenic. The arsenic will be leached out from the rock, it go to the groundwater, and it will enrich the arsenic in the groundwater, which is causing a health hazard. Okay, so in Assam, in many districts, we have the more arsenic in the groundwater. Every mineral having a certain limit. Okay, so if it cross the limit, we call it contamination. Okay, so in our area in Assam, you have the rocks. Some of the rocks are having arsenopyrite. They leach out to the groundwater, and the groundwater will be enriched with arsenic, and they will flow toward the different area. Then which fluoride into groundwater. Okay, so you heard about the the disease fluorosis, one of the health hazard in the Karbi Anglong district. Okay, so this fluorosis is a disease which affects the development of the bone and teeth. Now, many people in some part of the Nagaon district and Karbi Anglong district having suffered from the disease fluorosis because of the groundwater is enriched with more fluoride. It crossed the permissible limit of the fluoride. So people are using those groundwater for drinking purpose for many years, and fluoride contamination was more. Okay, and they have been suffering from fluorosis disease. And this where from this fluoride come to the groundwater? From the rock fluoroapatite. Okay, in Karbi Anglong district, if you go, you will have many fault, many fracture, joints, and the stream and the river follow this fracture and fault. Okay, they flow through the fault or the fracture or the joints. And in Karbi Anglong, you have the rocks, granitic rocks, which are having apatite. Okay, now you know talc, gypsum, calcite, fluorite, apatite. In the Mohs hardness scale, apatite is also a mineral. So this apatite leaches the fluoride to the groundwater. Now this Karbi Anglong district, you have the granitic rock, which is consist of the apatite. This apatite leaches the fluoride for many years. Now this groundwater are enriches in this fluoride. Okay, and this fluoride causes the fluorosis. So if I go, I put certain point. So Karbi Anglong and engineering area of Assam have many uneven joints, fracture and faults, along which river and stream have cut their path to form relatively smooth valley. That means in Karbi Anglong, this hilly terrain, it is subjected to many fracture and faults. Along this fracture and faults, the streams and river follow their path. That means the rivers are flowing, streams are flowing along the faults or fracture. Okay, you heard about the Garam Pani? শুনিছানে?
Yes, sir.
ক'ত আছে?
Yes, sir.
গৰম পানী গৈছা নে কোনোবাই?
Yes, sir.
Sir, গৈছো.
Sir, number have you, sir?
Sir, yes, sir.